Hello everyone, welcome back to Conarchy YouTube channel. In our previous videos, we've been modeling this structure, going through the stress of applying our loads and everything, and now we are done. And I would like to thank each and every one of you who has been with us since the first video we uploaded. And now we are almost at the end of the build it tutorial. So we are done modeling our structure, our beams, our columns, our shear wall, and everything. And now we are the most important part, as in designing your structure, your slab, your beam, and everything. So today's video, what we are going to do now is design our slab. So it's going to be an interesting video, so just get seated and let's get into it. So if you've not liked the video or subscribed to the channel, please try and do so before we continue, and also turn your post notification on, so in case we drop a new video, you are going to get the update as soon as possible. And also just leave a comment in the comment section and just let's get interacting. So let's get started. So in today's video, as I said earlier, we are going to be designing our slab, and the reason why we are doing this first is because when it comes to designing of our structure, we design from top to the bottom. But when we are constructing the structure, we start from the bottom, as in the foundation, to the column footing, to the beams, slabs, and everything. But when we are designing, we start from the top. So I'm going to start with the slab designing today, and it's going to be very interesting. So when it comes to slab design in Etabs, it can be approached in two main ways, depending on the design methodology and how loads are distributed. So first of all, there are two methods, as I said. They are the stripped base and the finite element method. I'm going to take you through each and every one of them. So first of all, we are going to tackle the stripped base design. So with this method, it involves designing the slab by dividing it into strips, both longitudinal and transverse directions. The slab is analyzed as a series of one-dimensional beams, and the design is carried out based on the forces, that's the movements and shears acting on these strips. So we are going to define our strips and assign it onto our slab, and we are going to design the slab based on these strips. So first of all, you have to draw your strips on your slab. So let me place this in the plan view, so story 5, and we are going to draw the strips. So I'm going to attach a picture to you so that you see how the strips will look like once we are done. Yeah, so that's it. Okay, so for us to start, we have to draw our strips. So we are going to edit, and we are going to add or edit strip, and you add design strips. So once this box opens up, we are supposed to fill these boxes and everything. So the tower is T1, and the story, we are at story 5, and this is story 5. So based on the story you want to apply your strips at, you just select that story, and with the strips you assign it story by story. You can't assign it all together, so you can just assign it story by story. So story 5, add strip along Cartesian grid lines. You are going to check this, and we are also going to include middle strips, so you are going to check this box. So this is one of the important parts. So the grid system, that's G1, and the grid direction. So when it comes to this, we have to specify the direction X, and we are going to give it a strip layer. So we have X and Y over here, and we have A and B over here, and also others. So with grid direction, in the X direction, we are going to assign the A, and in the Y direction, we are going to assign B. So in the X direction, we are going to assign strip layer A, and with a strip width, you can input your own width of how you want the strips to be, or you can just leave it at auto calculated, and I'm going to leave it as auto calculated for the app to do that for me. So once I've selected all of these, I'm going to apply the first one, so the X. So you can see that these are the strips in my slab. This is the X direction, and I'm also going to apply the Y direction. But the Y direction, as I said earlier, we are going to assign the strip layer B. So our X is going to be the A, and our Y direction is going to be the strip layer B. Okay, then I also apply this. So this is what I was talking about as in the strips. So the Etabs is going to design the slabs based on these strips I've assigned over here. So it's going to check the movements and shears along these strips and use it to design this slab. And once we are done, we are going to talk about how the finite element analysis also works. So with this, you can also view the width of your strips over here. So let me bring it here. Let's say let's say you want to view only the strip layer A. So I'm going to uncheck the strip layer B, and I'll go to other assignments over here to show width. So the width of this strip, I'm going to just apply. So this is my strip layer A, and this is how the width is going to be. So with the shaded places here, this is the column, the strip layer along the column, and these are the middle strips over here. So this is the width here along this strip. So I can also go back and uncheck this A and check the B and see how the B is going to look like. These are the width. I can also check both of them and just apply. So these are the various widths for the both layers. So I'm just going to uncheck the width and just go back. So with this strip, you can just right click on this strip over here to see the properties of this strip. So I can just right click and you can see this is a middle strip over here. So we have a middle strip. That's why you see a middle strip over here. It's in the middle of the slab. And also looking at the geometry, you can see the segment length to be 18 meters. You can see 6, 6, 6, so 6, 3, that's 18. You can see the length of this strip over here. So as I said earlier, this and it's also a strip A, middle strip. Once I click this one too, you can see that this one is along the column. So this is going to be a column strip, but the other one is a middle strip. So we are going to design our slab based on these strips. So as I said earlier, this strip is only applied on the 5th floor. So you can also replicate this strip downwards as into the various stories. So before I do that, I have to select the strip. So select, then object type, and I can select both strip layer A and B. So select. So once it's selected, I can just replicate it downwards. So replicate over here at the edit tab. Then I can replicate it by stories. So to the story 1, and so when I place it on apply, you can see that it's showing me how it's going to replicate. So if I want it like this, I can just apply and I'll get the various strip A and B at all the stories over here. So that's how to do that as quick as possible, as in assigning these strips to the various stories. So once these strips have been assigned, let me take you back to the plan view. So once these strips have been assigned and we have this tab here, these are the design tabs. So I'll first have to define a combination I'll be using to design this slab. So define, and I have my load combination over here, and I've already created one for the slab. This is just an envelope where these are the various combos I created, and I created an envelope where I place all these load combinations in this slab. But let's say that you want to add a new combo. So maybe add design combos, default design combos. And with the other one, we selected concrete frame design, but here we are dealing with a slab, so concrete slab design. So you check this, convert to user editable, and you just click on OK. Once you are done, you are going to get all of these combination that I created over here. So just cancel. And also when you are doing your analysis and doing everything, and you just don't want to be checking all these one by one, you can just create an envelope like I've done for this slab. So add new combo, and maybe slab, you name this place slab. Then combination type, you change it from linear add to an envelope. So for the envelope, you can add various combos. So when you come here, you can just add this combo and the scale factor will be 1. You add this combo, all the combos you have, and once you add all of them, you can just envelope them as in they're in one package, then as a slab. So I'm just going to cancel. So that's what I've done here. That's why you can see the various combos in this slab. So once you are done, you just click on OK. You have your load combination now, and now you just run your analysis. Okay, so once the analysis is done, you can just go to the concrete slab design over here. You check this and you just view or revise the preferences you want in your design. So just click on this And looking at this is the design code. This is the code you'll be using for your design. That's the BS code. So BS 8110, that's the code I'll be using. And also you can go to your, these are the safety factors for steel and concrete. These are just going to be the same. That's the thing. And also we have clear cover for the top. You can change these values. These are the preferences, what you want to maybe let's say 20 mm. Okay, then the preferred bar size, you can maybe, let's say 12 mm. So it will show in red, signifying that you've changed the value. So value has been changed during the current section. So it turns red when you change the value. Then once everything is done, I can just click on OK. Then I'll just come back to, let me show the form. Okay, so I'll just come back to this. You can also do your rebar selection rules, the rules the slab is supposed to be designed with, the various bars you want and all those stuffs. And also, so once you are done with this, let me just click on just one strip and show you something. Okay, so let me select this strip and just come here. So this one, so strip based design, and it's going to show you that this strip is just the B. There's a middle strip, and rebar material, you can choose that maybe you want to use, this is the H1 we created, high yield, but maybe if you're using a mouse tool too, you can choose that over here. Then maybe the H that you had, H1, reduce life load factor is going to be 1. So okay, so once we are done with everything and everything is okay, maybe select your design combination too. So these over here, these are the combinations that I created earlier. So this is the slab, this is the envelope that I created with the various combos, and I've selected that and brought it here. So all these combinations are in this slab envelope. So I can just click on OK, or maybe if you've not created it, you can just move these combos here. So once I'm done OK, then I'll just start my design. So start design, and it's going to design this this slab. So I think the design is done. So let me just go to this. So come back here and display lecturer design. So once this opens up, you have your design base. So this is a strip base we are using. We also have finite elements. I'll come back to that soon. So strip base and impose minimum. So we are going to check this impose minimum reinforcement. For this impose minimum reinforcement, based on the code you are using, it's going to pick the minimum reinforcement for that slab. So with this, it's going to use the minimum for that. And also maybe you want to show the bottom rebars in layer A. That's layer A is the X direction. And also you want to show total rebar area for the strip. So this is the area of the strip. You can just apply that to see this over here. So this is just based on the strip that we created. It's going to show the total rebar area. So this is the area of rebar for this strip. So around this place is going to be, this is going to be 678,504. So this, let's take it like this is our bar. Our bar is going to run from end to end based on this strip. And also let me show for maybe in the B direction, for that one to its end to end, you can see that over here. And let me go to my top bar reinforcement. So if you understand how the detailing of slab work, I think this should be okay for you. So you can see that over here at the top, we have show top rebar. At the top, most of the bars are going to be at where the support are, specifying the hugging moments are high at. So most of the top bars are going to be at the support. You can see that these ones are the support. Then there's some form of curtailment over here. These bars have been curtailed, and this one, so there's another bar over this support, another bar, and this is the area 924. This is the area of bar along this or across this support. So this is it for the show total area for the strip. So you can also fill the diagram to see how the movements around this place is going to be. You can see that these movements are very high at the support and stuff. And also maybe you can just come here. So once everything is done, you can just specify the typical uniform reinforcements below. So here you can just define by bar size and bar spacing. So maybe you want to use your 10 mm bar at maybe 100 mm spacing for the top. So let's specify only layer A and show top rebar. So at the top, maybe 10 mm bars at 100 mm spacing. I'm going to apply this to see if they are okay over here. So once I apply this, you can see that all the colors or all the shaded colored stations are all gone, meaning the 10 mm bar at 100 mm is going to be okay for all these places. But along this support at the top, it's not going to be okay. So it's either I increase the bar size or I'm going to decrease the spacing over here to make this place okay for the design. So maybe let me say I'm going for 12 mm bars at 100 mm spacing. Let's see if it works for this place too. So you can see that it's gone. That means using 12 mm bars at 100 mm spacing is going to be okay for this place, but using 10 mm bars for all these places are going to be okay at that spacing that I created earlier. So let me go with the bottom now and maybe layer A for the bottom, and I'm going to apply. It's going to be okay because the bar is big here. So let me change it to 10 mm. 10 mm too is going to be okay at 100 mm, but let me increase the spacing to see to maybe 150 mm and apply. Still going to be okay. 200. Still, let me change it to maybe 500 and see. Wow, still it's gonna be okay. So with the 10 mm bars at this space, it's going to be okay for the layer A. Let me check for the layer B too. They are all going to be the same. So most of the higher bars, higher things are going to be at the top. You see, when I picked for the show top rebar, at the top we are using 500 mm, so it's too big. So maybe change it to maybe 200. So 200 is reducing. At this place you can just keep on reducing. So this is how you do your design and all those stuff. This is with the strip base. So let me go with the finite element. So with the finite element, you see for the strip base it shows the area of reinforcement at where the strips are, but with the finite element it shows the area of reinforcement at every place in the slab. So let me go with the finite element and just maybe direction 1. Direction 1 is the X. So top at the X, bottom at the X. Direction 2 is going to be my Y, and I'm just going to let me go with none and just apply. So this is the finite element base. So with this it can show you the intensity. You can look at the top rebar intensity, the intensity at each place. So the top rebar at this place is going to be 0, 0, 0, but when I get closer to the support with the top rebars, the hugging moments are higher than support. So once I get closer to the support, the intensity of rebar over there increases. So this is it for the finite element. So it's 0 in the middle, but once it gets closer to the support it goes high. So let me go with the bottom rebar and apply. So with the bottom rebar you can see the intensity over here. So you see bottom rebar intensity around this place is 4 something, and it's changing values because at every place it's going to be different. So let's say it's 4 around in that 4 area, 4, 7 something area in this place. So let me take you back to the strip base and just view the bottom layer, show bottom rebar at the layer B. Was it A or B? Okay, A. Then apply. Let me go for the rebar intensity. Looking at this, you see that it's around 4 something for this strip. For this strip is 4.7. This is going to specify for the various strips, but with the finite element it specifies for the whole place. So you see it's in that range. So it's going to give you the area of the intensity along at every point of the slab. So based on these values you get, you can use these values to also design your slab, and you are good to go. So you can just use these values and do your detailing and stuff at the various places. But looking at this slab with doing your slab design, because my story is very similar, I can just choose to design just the 5th story, and I'll just use the values I get or the output I get to design the various stories. Since it's a symmetric story, every story is going to be the same, so I can just pick one story and design that story and use that output I get for the various story. Because running your analysis or designing slab has a various outputs that is going to give you. So if designing many slabs is going to give you variety of outputs, so it's best to just design one slab and just use it for that. Etabs can be used for the design of slabs, but sometimes I also use CSI safe for my slab design, and just this for the frame design. So it's all good with that. So once you get this, we can, once the slab and everything is okay, we can now continue to our frame design, our beam and column, to see if everything is passing. So that's it for today's video. You can just go through to understand each one of them. I can't really explain everything in the app, so you can just be going through to understand everything. So that's it for today's video. Thank you for sticking with us, and we'll be continuing with the frame section too. So don't forget to like today's video and also subscribe to the channel. Thanks.